Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the related rates problem, which we will meet frequently in applications. Let's see the material. First, I will introduce the method we can use to find the related rate. And then we will practice two questions together about how to use the method. Here is the problem. Let me see. Okay, we call it the related rates problem. What does that mean? If in a question or in the application problems, and usually we have more than one variable, and therefore we have more than one rate or rate of change, which is the derivatives. Okay, and we know they are related to each other, and we have a purpose, okay, to find one rate given the other related rates. Imagine if we have this kind of problem, how to solve the problem. Okay, so here is a summary for the basic steps we can use to find the related rates. Okay, we have 1, 2, 3 steps. And first we need to build a model, or you say an equation, okay, and to describe the relationships between the variables, because we have more than one variable, put all the variables together. And the second step, we need to differentiate to the both sides of the equation, okay, of the model. And in this way, we can put all the related rates together in one equation, right? So we set up equation for the rates. And the last step, of course, okay, so we can solve the equation we found in the second step to find what the related rates we need. Okay, this is the basic 3 steps. And here we have one need to pay attention. Okay, and the second step, when we take a derivative, okay, usually we need the chain rule. We have to pay attention to this. And in the second step, when we take a derivative, which means what? We need to take a derivative to the independent variable. Okay, and usually the independent variable is the time t. Okay, and now let's see two questions we can practice about this method together. So the first, let's see here, and let's read the questions. If the radius of a spherical ball, we have a ball, the ball is increasing and has a rate, okay, and then the questions, at what rate is the surface area of the ball increasing when the radius is 8 centimeter? Okay, so first, what are these questions? How many variables do we have in these questions? Okay, so we're talking about the increasing of the ball. Okay, so we have the independent variable. First is the time t, right? T is in minute. And what is the dependent variable? We have 2 dependent variable. Let me highlight the dependent variable. The first is radius. The second is surface area. Can you see the rate? Therefore, we have 2 rates. The first rate is the rate of radius, which is given. That's 2 centimeter per minute, right? Increasing, therefore, that's a positive. The second rate is the surface area, the rate of the surface area. Which means what? Okay, this is the question, and we need to find this related rate and given 1 to find another. That's exactly this type of question, right? And do you remember how many steps do we have? We have 3 steps. Okay, the first, set up a model, okay, to describe the variables. We have 2 major variables, radius and the surface area. Of course, we know how to link these 2 together. We have a basic formula, right, already. So we build the model. And what the second step? Okay, so we're going to take a derivative to the independent time t, independent variable time t. Okay, and the last step, we solve the equation. Let me set up the model. How to set up the model? So first, we need to set up the variable. So we have area. I set up the area is AT, is okay, and A is a function of the time t. The second is radius. let me set up the radius, which is we use r. Radius is a function of t, and then we can build the model. So what is the model now? It's easy to build this model. What's the relation between area and the radius? Of course, is at. I ignore the t, which is a equals 4 pi times r square. Everyone know this, right? So 4 pi r square. And this is a formula we learned before. And in the formula, this is a model now. All you say is an equation. A is a function of t. R is also a function of t. So we did the first step. Now we link the two variables together in one model, right? Good. The second step, we need to take the value to the independent term t to both sides of the equation. Okay, let me see. So I take the value to the left, which is dA dt, right? Okay, so equals, the right is 4 pi, does not matter, that's constant. We have the linear rule, okay, linear property. And then is dt at r square. Why I wrote this? Because r is a function of t, therefore this is a composite function. Can you see? And now we take a derivative to the composite function. We have to use chain rule, right? Okay, so we have to use chain rule. Let me draw here. We have to use chain rule. Okay, so I use chain rule to get what 4 pi a copy. So we should times r is the inner, right? R square, so is the outer, which is the power function. Take a derivative is 2 times r, right? This is the derivative of the outer. Derivative of the inner, of course, is dr dt. You see, this is the chain rule we used. Then I put them together to simplify, which is a times pi r, and then times dr dt. Can you see? This is the second step. It's easy. Okay, now we definitely build the equation for these two rates, the rate of a, the rate of r, in one equation, right? And then solve this equation to find the rate that they ask. They ask what? Ask the surface area, which is the rate of the surface. The area is dA dt. Okay, the question is find the left side. So let's move to the third step, which is go to the question dA dt, right? And of course, I put a bar because they ask the rate of the surface area. Okay, when the radius is 8, which means what? Which means at r equals 8 centimeter, we need to solve this rate. Okay, so let me go into, and we already have the rate is a pi times r. What is r? R is 8. And what is dr dt? This is the rate given in the questions, which is 2 centimeter per minute. So everything we know, just plug in. See what do we get? We will get a pi, right, times r. What is r? R is 8. They already gave you. And then the rate of radius, which is 2. Okay, can you see? A plug, and then we get the answer. 64 times 2, 128 pi. This is already, right? If they ask you what is the unit, of course, we're talking about the rate of the area, which is a centimeter square. Don't miss the square, right? Per minute. This is from the question. Can you see? We get the answer for this question. Let's go over a little. So 3 steps always, okay? Build a model to link the variables. And then the second step, take derivative. And so we have equation of all the related rates. The last step is solve the equation to find the rates. There's 2 points I have to point out. Pay attention. So the first, not always when we solve the equation from the second step, the question not always ask you about the left side. Okay, sometimes they ask you about the related rate on the right side. Okay, so you have to resolve the equation definitely. This is the first. The second, can you see in our questions, dr dt is 2. Why is 2 not a negative 2? Because we look at the questions, the ball is increasing, okay, which means the radius is increasing. Increasing has the rate always positive. If we have a question is decreasing like that, so what? We need to find that the rate is negative, okay? The rate of change, which is the derivative, is negative, right? Okay, so that's 2 points we need to pay attention, okay, in the future. Now we have one more questions. Can you see here? Very similar. Okay, all we need to do is 3 steps, right? So now we move to the first step, build a model for the variable. What is the variable? See, this time we're not talking about the ball. We're talking about the rectangle. So we have a length, we have width, we have area. Can you see? Okay, that's 3 variables we need to link together in the model. And so we have 3 rates, right? Some rates are given, some we need to calculate, which is the rate of the area of the rectangle. Can you see the question? Okay, so now what do we do? Build a model. So the first set up the variable. Let me set up this way. I use area as this. I still use AT. You know the independent variable is t, right? Time. In this question, the time is second. Okay. And then we have the width. How wide is the rectangle? The rectangle should be, let me use WT. Is okay, right? And we have one more is the length. Let me use the length is L. So we have LT. All depends on the time t. Now, what is the model? So the model is the easiest model, okay? And the model is the area is what? W, the width times the length. Can you see how simple is the model? The second step, you know what to do. Take a derivative to this model or this equation. Of course, take a derivative to the left is dA dt. Let me see. So we have dA dt. T is the independent variable, so the left. What the right? Pay attention, the right now. W is a function of t. L is also a function of t. This is a product, right? So we have to use what? Product rule. Okay, be careful here. We have to use a product rule of differentiation. Still use red color. So now the first take derivative, which is dw dt, right, times L plus w times dl dt. Can you see this is the product rule? Okay, it's good. Now let me go back to the third step, which is resolve this equation. Can we see this equation will link all the related rates together? Which rate we need to find? So in the question, which is the rate, how fast is the area increasing? Which means the rate, the instant rate of change, or the derivative of the area, which is still the left side. Okay. Now we don't need to resolve, right? So we already have. We look at the right side. Do we know the rate derivative of W or the width? Yes, it's 2 centimeters per second. Do we know L? From the question is L, the length is 10. Do we know W is 6? Do we know the derivative of L, which is the rate of the length? We know it's given that 3 centimeters per second. Can you see? We know everything. Now we just plug in, right? So we get. So let me write the question, which is what the rate at what? At L, check the question, at L equals 10 centimeter, and when W equals 6 centimeter, okay? We need to solve this. Of course, from the second step, we have everything. Now I just plug everything in. What is the rate of W? Okay, so in the question, which is 2, right? What is L? L here, okay, and the limit, which is 10. Okay, so let me put 10 here. And what is W, which is 6? What is the rate of L? It's 3 centimeter per second times 3. And then do calculation. Super easy. 20, 18 put together is 38, right? So we have 38. Okay, that's the answer. Of course, what the unit? We still talking about the area. The area is centimeter square. This is the area. And the rate, which means per watt per time. The time is a second. Can you see this is the answer for this question? Okay, if we go back to look at the two questions, very similar, right? 3 steps. And that's all for this topic. And thank you. If you have any question about this topic, please leave a comment. If you like this video, please give me a thumbs up. And you are very welcome to subscribe to my channel for more videos. Thank you for your support. In the next video, let's see. Okay, so we are going to deal with the linear approximation, which is a method we can use to approximate the value of a function at a particular point. Hope to see you there. Thank you. Have a nice day.